Good afternoon, grade 12s. We are busy with our exam prep for technical science. We looked into paper 1 and we did a lot of things. I believe we exhausted it. We looked into the misconceptions, common errors, the mistakes that you were busy doing. So I'm quite happy because we did a portion in which it consists of more marks in the final examination. That was mechanics, and it's something like 93 marks. But now we felt that it's always best to try and balance between the two papers. Yes, we know that paper 1 is out of 150 and paper 2 is just 75 marks. But now we still make mistakes as well as in paper 2. So the idea is let's try maybe to do something of paper 2 as well, so that at least we've covered a few of paper 1 and a few of paper 2. So without wasting any time, with paper 2, yes, we know that the paper will be 75 marks. So this will be your grand total of 75 marks. But now this 75 marks will be broken down into two topics or strands there. So we'll have our matter and materials, and we'll have our chemical change. Then from this we are able to say, but can we break the 75 into something that we are able to know exactly where our marks are situated at? So matter and materials will be something like 36 marks. And then it means if matter and materials is 36 marks, it means chemical change will be something around, let me just say, plus minus 40 marks. It will be plus minus 40 marks. So what does it say to me? It says I must equally prepare for each and every one of them. But at the time of me coming here, I picked it up that majority of schools, due to unforeseen circumstances, were unable to complete this particular part. So because we are busy now with our holiday classes and extra classes, camps, trying to cover up for this particular part, I am not going to try and confuse you with this, but focus more on something that you have already done and try now to assist you in terms of getting maximum marks. So this matter and material will further go on and break into 3. So when it breaks into 3, it will be now naming of organic compounds, naming and structures. Then I will have chemical and physical properties. Chemical and physical properties. And then I will further have organic reactions. So maybe I should have said here we are looking at organic chemistry. So each one of them plus minus 12 marks, plus minus 12 marks, plus minus 12 marks. So this is where your 12 marks or your 36 marks is based. This is where now you say, how best can I be able to get my maximum marks? So I have created, we'll start with naming of organic compounds. I have created a strategy that if all of us can be able to apply, is going to assist us a lot. I said to myself, what is it that I can say about this particular organic molecule? So if I am given an organic molecule, this is just now a general overview before we get into questions and trying to answer exactly what is being asked. It says to me, somehow I need to be able to say something about the homologous series. I also need now to be able to say something about the functional group. From the functional group, I must also be able to give the IUPAC name. From the IUPAC name, I must be able to say something about the isomers. From the isomers, I must be able now to draw the structural formulae. And then maybe lastly, I can add the general formula. Let's stop there for now, because isomers, I can further extend it to your positional isomer, chain isomer, and functional isomer, but I don't want to get there for now, because I want us to try and see if this tree of life can work, because I'm going to try now and apply it to this particular question that we have. Should make it this way. Now, without looking at the questions that are given, it says the letters A to F in the below table represent 6 organic compounds. So I am given 6 organic compounds, no problem at all. But when I look at compound A, B, D, E, and F, all of them are IUPAC names. So the rule is I am going to close now 1. If I am given the IUPAC name as like I'm given in the table, so what should I expect? I expect to be asked something that has to do with the functional group, something that has to do with the homologous series, structural formula, general formula, or even isomers. Because already the examiner has given me what? Has given me the IUPAC name. So it means when I look at that organic molecule that is given to me, if it is an IUPAC name, then the possible questions that should follow should be functional group, homologous series, structural formula, general formula, or even isomers. But let's look at compound C. Compound C, we are given a structural formula. So if I am given the structural formula, maybe let me do this. If I am given a structural formula, the possible questions will be the homologous series, the functional group, the IUPAC name, isomers, and the general formula thereof. So it says to me, when I look at my table of organic compounds, I should be able, by the mere fact of looking at the table, I should be able to say something about A. From the name, because it is IUPAC, am I able to identify the functional group from the given name? Propan 1-ol. Am I able to draw the structural formula of propan 1-ol? Am I able to give the general formula? If there's an isomer thereof, am I able to draw or give the name of that particular isomer? So this is a rule that I've created to say, but from the table, these are things that I need to know. So when I study, for instance, when I work with butanoic acid, am I able to draw the functional group? Do I know to which homologous series does it belong to? Can I draw the structural formula? Can I write the general formula? Does it have an isomer? If I can be able to address this per homologous series, then everything somehow will be very easy for me. So if I am given a homologous series, then the same should apply to all of them. Because from the homologous series, I need to identify the functional group and maybe the IUPAC name thereof. So let's try and answer questions and see if this generally works. But what does it say? It says I need to learn more in terms of organic molecules. This is read work. This is more practice that you need to expose yourself to, because there is no way that one can assist you in terms of knowing the general formula. It's either you know it or you don't. So the only way of knowing your general formulas is for you to practice them over and over again. Now it says there at 3.1, the letter that of a compound containing a carboxyl group. A letter containing a carboxyl group. So a carboxyl group, we look into it to say, but what is it that they are asking us? They are asking us to identify the functional group. From what? From us being given the butanoic acid. So we are given that the butanoic acid, which is the correct answer, but now the examiner decided to ask for the functional group. Which compound consists of a carboxyl group? So the correct answer is B, but now we are given the IUPAC name. So can you now see the link between the information that is given and the possible questions that might follow? So tomorrow in the near future, we'll still give you the same organic molecule, but say now, draw the structure of butanoic acid. Give us now the general formula of butanoic acid. To which homologous series does butanoic acid belong to? It belongs to carboxylic acid. Thereof, does it have an isomer? Yes, it does. It has a functional isomer. You see? So it is just now a factor of saying possible questions will be based on this, depending on what information it's given. So this is an idea of us trying to help you and now predicting and closing the gaps before the question paper comes for the final examination. So we did say at 3.1, the correct answer is B, so it's just 1 mark. Now at 3.2, give the name of the IUPAC, or give the IUPAC name of compound C. What is compound C? Structural formulae. What do we have here from our pillars of life? We have structural formula. So let me do this. We have structural formula. We close now our structural formula. What do we ask? We ask now the IUPAC name. So can you see the link of the possible questions? So now they asked the IUPAC name. Tomorrow we'll ask the functional group, the homologous series, and the general formula. So be prepared to say, from these pillars of life that I'm giving you, somehow they work best. I'm calling them pillars of life because it's things that now are basis of organic molecules. So you might be laughing where you are, but now remember, this is just analogies for us to remember and make this science somehow quite easy for you. So the name there that we ended up with is something like 3,2 is 2-methyl butane. 2-methyl butane. So I must emphasize here, it's 2-methyl butane, yes, but the mistakes that we do: incorrect suffix, incorrect position of the functional group, the hyphen thereof. So if any of those is incorrect, it says now I did not apply the IUPAC and naming rules. So it's important always now to apply the IUPAC rules. So if you don't know your rules by now, please now follow it up and go through it for each and every single homologous series that we have. Because now the mistakes that we are finding more and more, it's you omit the hyphen, you use a comma. So know when to use your commas and when to use hyphens. And the suffix thereof is always key, because from the suffix you will be able to say what is it that I am giving, to which homologous series does this particular compound belong, because the suffix also forms part of the IUPAC name. So from it being an A, it means it consists of single bonds only. So from that, I am able to ask any possible question thereafter. And then it further goes on, a letter representing unsaturated and saturated hydrocarbon. Now, I am extending it further because now they're introducing an issue of saturated and unsaturated. So I'm going to say I have saturated homologous series, of which consists of saturated hydrocarbons, and also unsaturated hydrocarbons. So saturated, I am looking at single bonds. Unsaturated, I am looking at double bonds and triple bonds. So this is me now further extending to say, but in this homologous series, I can be able to identify saturated and unsaturated hydrocarbon. Hence, I said now, this is a map that we need to work with in order for us to get maximum marks. So what does it say? It says now unsaturated, it means I must be looking for double bond or even triple bond. So when I look at A, it's an alcohol, butanoic acid. This one is a single bond because we just said it is 2-methyl butane, then it means it is saturated. Then I am looking at hexanal, it's an aldehyde. I look at E, it's propene, then it says to me it is unsaturated because it contains double bond. Then I will be able to give the correct answer thereof. So the correct answer here should be 3,3. 3,3 should be something like E should be the correct answer. And then 1 mark for that. And then I'm going to assign a negative marking here because this was the only answer possible. Give a reason for your answer. So the reason is it contains double bond, or multiple bonds between, very important, between carbon atoms. Very, very, very important. Very, very important. then we can be able to give you your 1 mark, even though the keywords are double and multiple bonds, but this should be between carbon atoms. You see, so we are given a name, and then from the name we had to identify the homologous series first before we can identify whether it's saturated or unsaturated. So this is how I approach each and every question. So if I'm given a name, the expectation thereof should be anything outside this is going to be assessed. If I am given the structure, everything out of this pillars here will be assessed. So this is an idea of me trying to say, if you apply this, you can necessarily predict and not necessarily be spot on of what is going to be asked, but you should have closed now all the gaps for you to be able to get the correct answer. So let's look now into structural formula of compound F. Compound F, it's butane 2O. So butane 2O, we can draw to say we have 3.4. It will be 1, 2, 3, 4. But at carbon number 2, it must be a ketone. Then I must just ensure that each and every carbon has 4 bonds, because the way we mark here, the marking criteria will be, do we have the correct functional group? Yes, we do. Then we award a 1. The whole structure is correct. Yes, then we will award another 1 for that. Then you will be able to get your 2 marks. You will be able to get your 2 marks. So this is the key idea of us saying, if we are able to use these pillars, then somehow you will be in the right direction of getting the correct marks. Then the structural formula, the structural formula of the functional group of compound A. So compound A, they are saying now it's propane 1-ol. We are given the IUPAC name. I will refer to this because I want you to see the pattern, the trend of how questions are being asked. So once you have the trend, it's not a rule to say these are going to be the questions, but the chances are the same sequence will follow and the same trend will be applied over and over again. So we are trying to follow the trend and close those particular gaps as time goes. So the IUPAC name was given, propane 1-ol. So what did the examiner ask? The examiner said we must draw the structural formula of the functional group. So he combined the structural formula together with the functional group. So it means we need now to know also the structures of the functional groups from given the IUPAC name. So even if we're given the structure, the question will still come and say now, give the functional group or draw the structural formulae of the functional group. You see? So it still stands to say all these possible, these other pillars are part now of the questions to expect. So as answering that, it is 3.5. It's an alcohol. So it is COH, and then, must have now 4 bonds. I nearly put an H there. And then the molecular formula of D. The molecular formula of D. So the easiest way of doing that is to draw the structure D. So let's go and say at 3.5, 3.6, this is 3.5 molecular formula. because I cannot exactly just tell if I do not know the number of carbons, the number of hydrogens, and the number of oxygens thereof. The reason for me to do that is if it's just hexanal, I can somehow miss an H, I can somehow miss an oxygen. So the idea is, let me work with drawing the structure first, because the molecular formula indicates the number of each atom in the molecule. So I want to know how many carbons do I have, how many hydrogens do I have, and how many hydrogens do I have. So it will be easy for me to say it's hexanal, so I must have 6. So 1, 2, 3, 4, 5, 6. And then it's an aldehyde. I will have an H here, H there. So to avoid any form of a mistake that I can do, so and by so doing, I'll just have to confirm that each carbon has a maximum of 4. Then I will start with my carbon to say how many carbons do I have. I have 1, 2, 3, 4, 5, 6 carbons. Then 6 carbons. How many hydrogens do I have? Then I will count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then I will have 12 carbons. How many oxygens do I have? I only have 1 oxygen. Then I will have C6, H12, O. Then I will get my nice easy 2 marks. So this is a plan of saying for me not to make any form of a mistake. So let me work with that, and then I will be able to get the maximum marks. Lastly, the general formula of the homologous series to which E belongs to. I will repeat again. What are we given at E? At E we are given the function, the IUPAC name. So here is the IUPAC name. What did they ask? They asked now for the general formula. So there isn't a way or a standard analogy or an approach that I've came across for us to remember the general formula. Hence I said it's something that you need to go now and look into. It's something that you need to go on and now be able to say, I know the general formulas of each and every homologous series that I am expected to know. So if you don't know the general formula, that it should be something like 3.7, it should be something like CnH2n. If you don't know this, unfortunately, there is no way you can be able to get it right. So this is just a way of me saying, if you are able to use this, somehow it is going to assist you in terms of predicting or knowing exactly what the examiner is going to try and assess. Because if you study now anything that has to do with isomers, I will extend it further to say with isomers, we have 3 types of isomers. We have chain, we have positional, and then we have functional. So what would I have done? I would have taken the very same question and say, butanoic acid is there, which is B. Does it have an isomer? Yes, it does. Which type of an isomer will it be? It is going to be a functional isomer because it's going to move from a carboxylic acid to an ester. Can you see that? And then I can further go on to D as well and say, I have given you the IUPAC name for D. Can I ask isomers? Yes, I can. Does it have an isomer? Yes, it does. What type of an isomer? Functional. Because it's an aldehyde, it will move now to a ketone. So it means this will be a structure of me when I sit down, plan my lessons, plan how I revise. It's something that I need to close the gaps on. So because anything can be asked, yes, but this is now a basic structure that we can work on. So this is the part of nomenclature, and this is the part where I need to be able to say I am getting now the maximum marks thereof. So that is now branch number 1 of what we said we are going to look into, because we did agree that each branch now has naming of structures. After naming of structures, we have physical and chemical properties. So we have done this one, naming. We tried to exhaust it as much as we can from this now pillars of life. Can we do the same maybe, or try to have an application or a way of minimizing the mistakes that we are going to do when we work with chemical and physical properties? Fine. So before we answer questions, we try now to develop a strategy and a mechanism that I can work with. First things first, I am going to have my physical properties, which will be boiling point, my physical and chemical properties, melting point, and vapor pressure. So those are the 3 that I am expected to know. I must be able to give definitions. I must be able also to know the relationship between boiling point and vapor pressure. So, but now I need also to know the factors thereof that affects boiling point, melting point, and vapor pressure. So it means I must branch it down to say I can have now the chain length. I can have now number of branches. The last one will be the functional group. 100%. Then I further look into, for me to talk of chain length, it means the compounds I'm comparing must belong to the same homologous series. Then if I am looking at branches, it means now also they must belong to the same homologous series. Because the part of having different homologous series is accommodated by the functional group. So it says now different homologous series. Homologous series. So there I am comparing an aldehyde with an alcohol, an alkane with an ester. It's fine, because that part is accommodated there. But this does not give me any more information in terms of when do I know its chain length and when do I know its number of branches. So I can say here, these ones, there must be isomers of each other. And if they are isomers of each other, it means they must have the same molecular mass. Molecular mass. This is now just a crash course for you to understand as we move forward. Then I have chain length, same homologous series. But if it's chain length and number of branches and same homologous series, it does not necessarily say anything to me. It does not confirm. So it means I need to add something this side as well that says now here we are going to have a different molecular mass. Different molecular mass. Different molecular mass. So once I have agreed to say the compounds that I'm comparing, they have the same molecular, they belong to the same homologous series, check. Do they have the different molecular mass? Check. Then it means the examiner is trying to ask me something about chain length. Do they belong to the same homologous series? Check. Do they have the same molecular mass? Check. Are they isomers of each other? Check. Then it means the examiner is trying to ask me something about now what? Number of branches. Further on, if the examiner is going to ask me about functional groups, definitely he's going to give me different functional groups. So this is just a basic course or a crash course for us to understand when is it chain length, when is it number of branches, and when is it the functional group. So once we are able to do this, then we'll be able to reason accordingly. And us reasoning accordingly is just applying the correct principles thereof. Looking at the question that was given, the table below shows vapor pressure of 3 organic molecules with varying groups of atoms that determine chemistry of the molecule. Give one scientific word for the phrase in capital letters. Okay, it's functional group because the functional group is defined as a group of atoms, a bond that determines now the physical and chemical properties of an organic molecule. So there we are going to say at 4.1, it is a functional group. It is a functional group, 100%. But now it says you will not be able to answer that provided you don't know your definition. So it's basically asking you to give a definition of what is a functional group. Then we further look into the table. Write down the name of the homologous series to which compound B belongs to. Then I go to, because I am still busy with my organic molecules again, I want to remind you, what is it that we are given here? We are given the IUPAC names. So we have the IUPAC name. What did the examiner ask? To which homologous series does now compound B belong to? Can you see that? So from this, the organic chemistry continues further on and further on and further on. So by so doing, it says I can easily see or tell for that the homologous series to which B belongs to should be now an alcohol, and then I will be able to get my 1 mark thereof. But now it says write down the letter of a compound that has the highest melting point. So the letter that has the highest melting point is A. It's A because the relationship is that the lower the boiling point and melting point, the higher the vapor pressure. So in this case, the lower the vapor pressure it means the higher the melting point. So the correct answer here should now be just B. Why? Because A has, A because it has lowest vapor pressure. Lowest vapor pressure. So hence I said you also now need to know the relationship between the three of them. We further move on. It says give a reason for your answer. I have already done that. Now fully explain why the boiling point of compound B is lower than that of compound A. So you cannot reason just because you want to give your reason. You need to look at what is it that you have and what is it that you don't have. So we are given here that this one is an ethanoic acid, this one it is an alcohol. So what are we comparing? We are comparing the functional groups. Ne? So if I am comparing the functional groups, so I should be able to answer in such a way that let's develop another way of us not losing maximum marks in this particular case, because we'll always compare either 2 or 3 compounds, but the comparison will always be there because we want to assess whether you are able to give the correct or identify the correct types of intermolecular forces. So I will always have bullet 1, bullet 2 to say compound A has, and then compound, let me not write A, let me just make it a dash, has, and then the intermolecular forces, allow me to write EMF for the sake of time. The intermolecular forces of are stronger or weaker than the intermolecular forces of, and then we say more or less energy is needed to overcome the intermolecular forces of compound So once I have this, everything becomes easy for me because I would have been able to know the pattern that the examiner is going to ask. It comes with more practice. It comes with emphasis of exactly what the examiner is trying to ask. So in this case, the examiner is asking me to explain fully why the boiling point of B is lower than the boiling point of A. So the first thing is for me to commit myself and say, now I am talking of compound A. So compound A has hydrogen bond. I will write it somewhere here to create space. Has hydrogen bond. Ne? But because they contain the same type of intermolecular force, I will also say compound B has hydrogen bond. I want to show you the reason why it is 4 marks. So for saying hydrogen bond for each one of them, or for both of them, it will be just 1 mark. But now we further extend it to say, but it means somehow here there has to be a difference in one of the two, because the boiling points are different or the vapor pressure is different thereof. So it says here we have propan 1-ol, so which is compound B. So compound B has only one side one side of hydrogen bonding. And then compound A is ethanoic acid, has two sides of hydrogen bonding. You see, that is where now the other mark is sitting, for that 2 marks. Then we further move on. The intermolecular forces of A are stronger. Now you have to just choose between stronger and weaker. You see, that is what now is important. So for choosing stronger than the intermolecular forces of B, then you come again, it becomes now choose between the correct, the two given words in brackets, more or less. Then we say more goes hand in hand with strong. Then more energy is needed to overcome the intermolecular forces of E. So it's a pattern that once you understand, everything becomes clear. Once you are able to get a way of what the examiner is looking for, because we are comparing in terms of the type of intermolecular forces, the strength of the intermolecular forces, and the energy thereof. Other things do not change. I will make an example with chain length. So for chain length, because they belong to the same homologous series, it means they must have the same type of intermolecular forces. So we'll say just compound A has London dispersion, compound B has London dispersion. So but now it says there has to be something that is different. So the longer the chain, the stronger the intermolecular forces. Then you commit yourself to say compound N has a stronger intermolecular forces than B. Then more energy is needed to overcome. So it will forever be the same principle that you go back to. So don't write paragraphs and sentences. We have these 4 important bullets that we need to follow. Because now, even if I was about to compare the 3, let me add the last one. You see the last one here, it's propanol. It was going to be easy for me because I identified the intermolecular forces of A, intermolecular forces of B. Then I will put another bullet here to say compound C has now what? Dipole forces. So I will still get my marks because I was clear and committed to say exactly which one am I talking about, which type of intermolecular force is found in each organic molecule. I hope that is clear and will avoid writing a lot of information that is unnecessary. So let's just have the 2 bullets at the top, or even 3 when we compare different functional groups, such that we are able to identify each type of intermolecular force that is found in each one of them. Thereafter, we will be able now to say which one is stronger between the 2, and then more or less energy needed. So bullet number 2 and bullet number 3 and number 4 is just an issue of choosing which one is relevant. But now the idea is stronger goes hand in hand with more, and then weaker goes hand in hand with less. So we are creating a rhythm, we are creating a strategy that will assist us in terms of getting our things right. So now the very same thing goes again here. Fully explain why vapor pressure of compound B is lower than that of compound C. So you're comparing B and C. So do they belong to the same homologous series? No, they don't. So if they don't belong to the same homologous series, definitely the examiner is asking for the functional group. So if it's the functional group, I will say compound B has one side of hydrogen bonding, compound C has dipole. Can you see that? So already it says to me, I am in the right direction because I have identified that compound B is an alcohol, has one side of hydrogen bonding. Then compound C, it's a propanol, so it has dipole-dipole. Thereafter, the intermolecular forces of B are stronger than intermolecular forces of C. Thereafter, more energy is needed to overcome the intermolecular forces of B. So this is just a pattern, a rhythm that you need to work with. Once you are able to do this, even if you are given a graph of different boiling points, melting points, or even vapor pressure, but the idea is first identify what is it that you are being assessed on. I cannot emphasize it further. So that was it about physical and chemical properties. I hope now you understand fully as to when and how to identify which factor has been assessed. So the factor that is being assessed will help you in order for you to reason accordingly. Because if we belong to the same homologous series, automatically we should have the same type of intermolecular forces. Then there has to be a different factor that influences the differences in our boiling point, melting point, and vapor pressure. So unfortunately, the time has run out. The idea was to do as much problems as we can, but where we did not get any further information with, like question 5 and 6 and so on, kindly talk to your teacher. They know where to find us, and then we will kindly be able to assist. So now for me, Mr. Nambani, I will easily say thank you very much for your time today, and hopefully we'll meet again very soon, and all the best moving forward for your final examination. Remember, the best thing to do is to prepare as early as now to avoid the panic, to avoid the stress that comes with examinations. So let's start preparing as early as now. The exam guidelines are out there to give you the guide for the exam. So kindly use them and the definitions that are terms and definitions that are provided to you. So from me to you, all the best, and thank you very much.